Okay guys, what we're going to talk about in this tutorial is how to find all of the solutions of a function. And what I always like to do first is determine how many solutions I have. And to figure that out, we're going to take a look at the degree of a function. So in this case, my degree of this function is 3. That means that when all is said and done, I should have a total of 3 solutions. So I got to make sure again at the end that I have 3 solutions. So how are we going to go about finding them? Well, we have a couple different techniques that we can use. The kind of older way of doing things is to create what's called a P over Q list, which I'm not going to do right now. I'm going to do that at the tail end of the video because most classes don't require you to use a P over Q list. So what I'm going to do instead is I'm going to use my graphing calculator to try to find one of the 3 solutions. Okay, now I like to use this online calculator called Desmos. So what I'm going to do is I'm going to go into Desmos and I'm going to take the function that I have here and I'm going to graph it. And I encourage you to do that as well. So go ahead and graph that initial function. So I'm going to go in here, I'm going to say 15x cubed plus 61x squared plus 2x minus 8. Okay, and this is the graph that's coming up. Notice how I can zoom in, zoom out, and I can see that I have 3 solutions, the 3 places where it's hitting the x-axis. Now, as I go through those 3, notice that this first one is a decimal. Now, I would imagine most of you would see that that is 0.3 repeating is the same as 1/3. If I go to this one, I have negative 0.4. Also, I could represent that as a fraction. But if I go over to this one, it's a nice and clean negative 4. So considering I only want to take one of the 3 right now, it makes the most sense to take negative 4 because that's the easiest number to work with. So I'm going to go back and I'm going to say, all right, well, one of my solutions I know is x equals negative 4. And again, I pulled that strictly from the graphing calculator. What I'm going to want to do now is I'm going to want to extract that 0 from the function. And in order to do that, I'm going to use synthetic division. So I'm going to take the 0 I just got, which is negative 4, and I'm going to set up synthetic division. Now a quick reminder about synthetic division. As we're lining up our coefficients, we want to make sure that we aren't missing any terms. Notice how I have x cubed, x squared, x, and then a constant. That means I'm not missing any terms, so I'm not going to need any placeholders. I'm just going to line those up. So 15, 61, 2, and negative 8. Now, one thing that I always like to do is I know that my remainder should be 0. If I'm doing things right, I should get a remainder of 0. So what I like to do is I like to go ahead and put a 0 in as almost like a self-check here. If I don't get a 0, that means I know I'm doing something wrong. Okay, now I would imagine you already know how to do synthetic division, so I'm going to go through that pretty quick. So I'm going to drop the 15, and that's going to leave me with 15 there. Now I multiply 15 times negative 4. It's going to give me negative 60. Add those up, I get 1. Multiply again by negative 4. Add vertically, gives me negative 2. Multiply by negative 4, 8, and perfect. So again, if you don't get a remainder of 0, that means either you took a number that isn't a 0 or you've done synthetic division wrong. So now what I can do is I can take my polynomial here that's left over, 15x squared. Remember, always take 1 off the power when you write the new polynomial. I'm going to take that new polynomial and I'm going to set equal to 0. Now, we saw from the graphing calculator that those other 2 zeros were numbers that were what we call rational. Remember, we had 0.3 repeating. That's the same as 1/3. We had negative 0.4. That's the same as negative 2/5. So since I know they're rational, I can go ahead and do some factoring. So that's what I'm going to do. Now, again, we already know what the answers are, but let's pretend that we didn't know what they were. So I want 2 multiples of 15. I'm going to do a little guess and check here. So I'm going to try 3x and 5x. And I need 2 multiples of negative 2. Again, kind of helps I already know the answer. So I know the 2 is going to go here, and the -1 is going to go here. Keep in mind, though, that we would just factor like we've already learned how to factor. Or if something is not factorable, we'd be using either completing the square or the quadratic formula. So based on this factored form, this factor gives me a solution of 1/3, whereas this gives me a solution of -2/5. Okay. Now, anytime you're writing your final answer, you want to be very, very clear about what the final overall answer is. So I don't want to just leave it like this. Everything's kind of spread all over the place. So I want to come down and I want to list all of the zeros. And I'm going to go ahead and use set builder notation. It kind of depends on how you write answers in your own class, but I'm going to go ahead and write set builder notation. So I had -4, I had 1/3, and I had -2/5. And the order that you write them in doesn't really matter. You just have to make sure that you have all 3 solutions. So let's recap what we did. The first thing we did is we grabbed a 0 from the calculator. So remember, I got this -4 from the calculator. That's the number that I used for synthetic division. And then once I did synthetic division, I factored the remaining quadratic. Keep in mind that if it wasn't factorable, I would have used quadratic formula or completing the square, whichever technique you feel more comfortable with. So if you're going to be allowed to use your graphing calculator in your class, then that's what you want to, that's the order of steps that you want to go through. But let's talk about what if you were not allowed to use your graphing calculator? How could you go about finding all of the zeros? So I'm going to go ahead and take this original function and let's start a new screen here. So this is the way that we used to do it prior to graphing calculators kind of entering the classroom. It's what we call a P over Q list. Okay, so let me write that first here. So we've got a P over Q list. Now P is the number at the back, my constant, whereas Q is the leading coefficient. So what I'm going to do is I'm going to list out all of the numbers that are factors of P, and I'm going to divide that by all of the factors that are of the leading coefficient, in this case 15. So my factors of 8, I have 1, 2, 4, and 8. Those are all my factors of P. My factors of 15, Q, are 1, 3, 5, and 15. Now we write this as just as a list just like this, but keep in mind that what this really means, I'm not going to go through all of them because it'll take forever here, but what that means is I could have 1 over 1, I could have 1 over 3, I could have 1 over 5, etc. I could have 2 over 1, 2 over 3, 2 over 5, 2 over 15. So I have a lot of combinations. But what this list is, this is the list of possible rational zeros. So these are the only possibilities. Now I say only kind of loosely because that's a lot of possibilities. Keep in mind, I only have 3 zeros, so a lot of these are totally irrelevant. And I might only have 1 that's rational and 2 that are irrational or imaginary. So this list can be a little bit cumbersome. So what we would do, this would be what you'd do if you weren't allowed to use a graphing calculator at all. You would just guess a number. You would guess a number from this list and try it out using synthetic division. I always like to just start with something like 1. So I would try 1 with synthetic division. Okay, so let's go ahead and do 1 just so you can see what the process is. So I'd line everything up, 15, 61, 2, and -8. Now remember, I'm looking for a remainder of 0. That's what I want. Now let's see if we get it. So I'm going to drop down 15. 15 times 1, 15. And then that's going to give me 76, 76, 78, 78. Now, clearly, that does not work out. So what that tells me is 1 is not a 0. And then I'd go try another one. I'd try 2, and then I'd try 3, and then I'd try 1, 3, you know. So I could just go on and on and on. I'd have to keep on doing that until I got a remainder of 0. Now, if I go back to page 1 here, I would have kept on trying until I got this -4. -4 would have been the first time I got the 0, assuming we hadn't tried 1/3 or -2/5. So when you don't have the graphing calculator, it's going to take much, much longer to find the zeros because we might have to do several rounds of synthetic division. Okay, so let's kind of recap everything that we said. Number 1, determine how many zeros you're going to have. That's based on the degree. Use a graphing calculator if you're allowed to do so. Remember, I like to use Desmos because it's nice and easy to look at. Zoom in, zoom out, look for the clean 0. Again, I use -4 because it was clean. Okay, once you have a clean 0, do synthetic division. That will narrow it down to a quadratic. Factor it, use the quadratic formula, use completing the square. That'll give you your remaining zeros. Okay, well, I hope that helped. Good luck to you on those. Remember, follow the process. Graphing calculator, pull a 0, synthetic division, and then factor or use the quadratic or completing the square. All right, good luck on these.